In this video, I'm going to go over homework number 5. So what is homework number 5? Mr. Berry, who is 81 kilogram, is going to be jumping up. In order to jumping up, he needs to create some acceleration. Let's say he creates 40 meter per second every second. That's how much acceleration he created by crouching, by dropping himself, pushing to the ground, and jumping off. Now, what are we trying to do? Will he feel heavier or lighter? Let's see before he jump up, what would he feel? Okay. All right. So rest. All right. So when he is at rest, his weight is going to be equal to the normal force. So he would feel normal. He would feel normal, and scale will read his mass is 81 kilogram, and the scale will read 81 kilogram because net force is 0 and acceleration is 0. Very simple case, very simple. When he is at rest, he will feel normal, and the scale will read 81 kilogram is because the net force is 0 and acceleration is 0. But when his acceleration is 40 meter per second square, and that's the different story. That's the different story when his acceleration is 40 meter per second square. How did he create 40 meter per second square? By dropping himself and moving off very fast. He will feel heavier is because if he has a scale underneath of his feet, this is a scale, heavier, but can we support this experience by doing physics? Yes, we can. Remember, his mass is still 81 kilogram. He feels heavier means there would be apparent gain of mass, and we are trying to see whether the scale can support this experience. So let's do the force body diagram first. In the force body diagram, if you have Fg and if you have a normal force, understand that normal force is bigger than Fg, so Fn is bigger than Fg. So that means there is a net force. There is a net force at upward direction. So if there is a net force at upward direction, that means there is acceleration at upward direction. So now we can use Newton's second law to write the formula. Newton's second law said F is Fx and Fy. What type of F? That means all the forces acting on the body. So all the forces acting on the body at the x direction is simple. 0 is because no one is pushing or pulling from sideways. So that's obvious. Now at the y direction, the force is positive. How do we know? Is because Fn is bigger than the Fg. Okay, so then we're going to use that, and we're going to use the free body diagram to write the equation. So free body diagram tells us that F is equal to ma. All right, so all the forces at the y direction we're going to add up. What are the forces at the y direction? We have two forces, Fn and Fg. So let's write them up. Fn plus minus Fg is because they are not equal. They are not at the same direction. So ma. So Fn minus mg is equal to ma. So Fn is equal to mg plus ma. So Fn is equal to mg plus a. So Fn is equal to 81, he is 81 kilogram, g is let's say use 10, and acceleration is 40. So Fn is 80. The scale will read 405 kilogram. So he is 81 kilogram. He is 81 kilogram. He is only 81 kilogram, but scale will read much more than that. Scale will read 405 kilogram. So he feel much heavier. So we support, that was our claim. Now